All right, good morning, guys. So today we're going to go over how you do adding parallels and resistors in regular circuits and then in combination circuits. Apologize about the video not coming out yesterday, Wednesday. Something happened with Zoom, it didn't record. So here we go. So I already posted the answer key, but here's the front side. Just go over each one real quick, and then we'll take a look in more detail on the back side of the work from yesterday where we have the combination circuits. So for number one, it was just a quick recap, series and parallel. So again, to find resistance in series, just add up your resistors together. So 5 plus 5 plus 5 is 15. And then in parallel, it's 1 over 5 plus 1 over 5 plus 1 over 5, which is 3 over 5. That's 1 over r. So we have to flip that upside down. So r is 5 over 3, which is 1.67. So just remember, in series, add them together like normal. And in parallel, you have to do the fractions. And at the end, you must reflip that number over. Question 2 is just a simple series circuit. So we just add our resistors together and we get 232 ohms. In question 3, it's a parallel problem. Oops. All right, so we have to do 1 over 20 plus 1 over 40, which becomes 3 over 40. So 1 over r is 3 over 40. So r is 40 over 3, or 13.3 ohms. And the same thing for number 4. It's just 4 resistors. So it's 1 over r is 1 over 10 plus 1 over 20 plus 1 over 40 plus 1 over 80. If you find the least common denominator, which is 80, you end up with 1 over r is 15 over 80. Therefore, r is the inverse, or 80 over 15, which is 5.33 ohms. Right, so that is the front side. All right. Now we have the back. So these are combination problems. If you look at this first one, we have a parallel branch, which is in series to this. So whenever we solve these, we want to basically solve our parallel portions first. So if we look here, R2 and R1 are wired and parallel to each other. Okay? So we're going to find out whatever the resistance is for just these two first. So how do we do that? Well, we know that our resistors are labeled. So we have 1 over R is 1 over R2, which is 20, plus 1 over R1, which is 10. Okay, that's 3 over 20. So R is 20 over 3, or 6.67. So here's what it actually does. Now that we found out what this R is, let's just call it, it's a new resistor, all right? So since we've already had 1, 2, and 3, I'm going to call this new resistor 4. So what we've done is we've basically removed R2 and R1 from the equation, and we've replaced it with a new resistor, which we're calling R4. Now, I know it's a little tricky to see over here. So R1 and R2 are gone. They've been replaced by this new resistor R4, and we know R4's value is 6.67. Well, if we look now, R3 is in series with this new resistor R4, because these are gone now. These don't exist anymore, R2 and R1. So because it's in series, we just add our two resistors together. R3's value is 40. This new resistor is 6.67. So if we add up those two numbers together, 40 plus 6.67 gets you 46.67 ohms. Right, so that's how we do the first one. So again, we took care of our parallel part first. We built a new resistor. We basically found up a new resistor. And then in turn, these were in series. We added them together. So let's look at number 6. So we have a parallel branch and another parallel branch. So the first thing we have to do is we have to find out the equivalent or total resistance for this parallel part, and then we'll do the same thing for this parallel part. So for R1 and R2, 1 over R is 1 over 100 plus 1 over 250. And for the other ones on the bottom, it's 1 over 350 plus 1 over 200. So I'm going to real quick find out what those give you, and then I'll flip it upside down as well. So the total resistance for R1 and R2 becomes 71.4 after you find out 1 over R and then take the inverse. Right? And then when we do the same approach, for that one we get 127.3. So I did 1 over r plus 1 over r, same thing down here, and then without writing it down, I found out the inverse, and that's what the true values are, 71.4 and 127.3. Okay, here's what we did. We're going to call these, again, two new resistors. Since we've already done 1, 2, 3, and 4, we're going to call them 5 and 6. Okay, so this is R5, this is R6. I'm going to replace R1 and R2, and I made them now R5. I'm going to replace R3 and R4. I'm going to make them R6. So I just cross these guys off that are already there. And I'm just going to draw in the new resistors, R5 and R6. So, now that we have R5 and R6, they are both wired together in series. R5 is in series with R6. So how do we find out the resistance in series? We just add them together. So 71.4 plus 127.3, and we get 198.7. All right. 7. So again, we're going to start with our parallel portion. These two are in parallel. So the first thing we're going to do is we're going to find out the total resistance between just these two branches using the parallel method. So 1 over R, okay, is 1 over 20 plus 1 over 40. Okay, that ends up being 3 over 40. And when you flip it upside down, you get 40 over 3, which is 13.3. All right. Now that we found these two out, we can replace them not with individual values, but with just this 13.3. Well, now this resistor and the new resistor that we've built are in series. We add them together. So 13.3 plus this resistor's value. And this resistor happens to have a value of 10. So 10 plus 13.3 gets you 23.3 ohms. So that's 1 through 7. All right, 8. 8 seems a little tricky, but start from the outside in. So we have our first parallel branches over here, but we have an issue in this parallel branch. 15 is good, but we can't use the 1 and the 5 separately. So we say, okay, how are 1 and 5 wired together? 1 and 5 are wired together in series. And if they're series, we can just add them together. So instead of thinking of this as 1 and 5, let's combine them and turn them into a single resistor that has a value of 6. Now the 6 and the 12 are wired in parallel. So we're going to find out the total resistance between the 6 and the 12 resistor using the parallel method. So 1 over R is 1 over 12 plus 1 over 6. That's 3 over 12. Therefore, R equals 4. So we have basically combined the 6 ohm and 12 ohm resistor, and we're going to rewrite them not as 12 or 6 anymore, but as the number 4. So I'm just going to cross off the 12 and make it a 4. And then I'm going to cross off the back part of the circuit because, for argument's sake, it no longer exists for this problem. So now our circuit looks like this. So here comes the current. It comes in through here, all right? And now it has a choice. It can either go through the 3 and the 7 and back out, sorry. Right? It can come in through here, go through 3, 7, come back out, or it can go straight through the 11, down through the 4 and back out. So the 11 and the 4 are wired together in series, and the 3 and the 7 are wired together in series. However, the 11 and the 4 are parallel compared to the 3 and the 7. So how do we do this? We're going to make the 11 and 4 into one resistor. And since they're in series, 11 plus 4 becomes 15. And the 3 and the 7, we're going to combine into one resistor as well and make that 10. So I'm going to draw what this would look like on the back. So now it kind of would look like this. That front thing becomes 10 because 3 and 7 combine to form 10, and the 11, the 4 combine to form 15. And now it looks like this. And now this is a simple parallel problem. So 1 over r is 1 over 10 plus 1 over 15. Okay? That ends up getting you 6, 9 over 15, 10. Yeah, so 1 over 10 plus 1 over 15. All right, it's 0.1667. Flip it upside down, and you get 6. I know the answer is 5.8. All right, that's all just some rounding and stuff like that. Don't worry about it. If you got 5.8 or 6, you're both fine. All right, and then there's our answer. If you still have any issues with this, don't hesitate to let me know. Again, we're going to practice this combination thing for a couple days straight, and then we'll move on. Thank you guys, and I'll see you guys soon.